Today we're going to take a look at the algebraic test for symmetry. We're also going to decide whether a function is even or odd. We have a function here, 7x cubed plus 4x minus 2, and we're going to take a look at each test individually. First, we'll take a look to see if the function is symmetric about the x-axis. To determine whether a function is symmetric about the x-axis, we want to replace every y in the function with negative y, and then perform our algebraic operations and see if the function comes out the same as what we started with. So what we'll do is first replace every single y that we have with a negative y. In looking at this function, we don't really see a y there, but remember that f of x is the same thing as y. Here we see that I've put in the y for the f of x, and I have now changed the y to a negative y. That's the first step in the test for symmetry about the x-axis. The second step will now be to try to get the y by itself just using algebra and see if the two functions look the same as when we started the test. Remember that in algebra, in order to take a negative off of a variable, you just change the signs on both sides by multiplying both sides by -1. So here I've multiplied both the left and the right by -1, and what that does is that makes the y on the left a positive y, and it changes all of the signs on the right hand side. So now I'm left with -7x cubed minus 4x plus 2. As you can see, the original function and the new function are different. Since they're different, this is not symmetric about the x-axis. If they had been the same, it would have been symmetric. So I'm just going to make myself a little note that says, no, it is not symmetric. Just NO. Just to tell myself that it is not symmetric so that I can go ahead now and perform the next test. To perform the test to see if a function is symmetric about the y-axis, we do basically the same thing we did before, except instead of replacing the y's, we will now replace the x's with negative x's. So we'll start out our equation by changing the f of x to a y, just so we can see what's going on, and then replace all of the x's with negative x. So here I've simply changed the f of x to a y so that it looks like a problem that we're used to seeing. We're used to seeing the notation of a y instead of an f of x. Now I'll just change all the x's to negative x. All I've done here is replaced every x with negative x. Now, when we do the algebra on these, we need to be careful and make sure we get our signs right. When we look at this first one, this one here, we have a negative inside parentheses. When you take a negative and you raise it to the third power like this one's done, you would have a negative times a negative times a negative, which would make that whole expression negative. In the next case, we have a 4 times a negative. The negative's inside the parentheses, so it's like a -1. So 4 times -1 is a -4. And then we have the -2 that has no change in sign. Take a look at the original expression and the new function that we have. They are different. If they're different, then this function is not symmetric about the y-axis. So I'll simply make myself a little note that says no, so that I know this one is not symmetric about the y-axis. Next, we'll do the test to see if this function is symmetric about the origin. For the test for the origin, we must replace the y's with negative y's and the x's with negative x's. So it's like doing both tests in one problem. Once we do the substitution, we just need to do the algebra. I'm going to work on the x's first. Since I just did that in the previous test, I should be able to get my signs right. Remember, a negative that's cubed is a negative. So we're going to look at the right-hand side of the equation first. We've changed the right-hand side of the equation. We haven't looked at the left-hand side. The left-hand side has a negative y on it. We don't want a variable with a negative on it on the left-hand side, so we're going to change that to a positive y, and if I change that to a positive y, I have to change all the signs on the right. Now, looking at the new equation and the previous equation, they are different, so this test is also null. This expression, this equation, is not symmetric about the origin. So in this particular problem, it is not symmetric about the x-axis, it is not symmetric about the y-axis, and it is not symmetric about the origin. Only if the two equations match up would you say, yes, they are symmetric. So once you get finished with doing the algebra, if the two equations match up, the previous one and the new one, then you would say yes. This problem also asks us to determine whether this function was even, odd, or there is a third choice, which would be neither. So we'll go back and look at that part of the question. Being even or odd are just definitions. When we look at the definition on page 202 in the current textbook, it says that if we have an even function, the function is symmetric with respect to the y-axis. So, if when I had done my test, this one had been symmetric about the y-axis, you would say that it was even. If we do our test and it is symmetric about the origin, you would say that the function is odd. There is nothing for being symmetric to the x-axis, so you don't worry about that one. You're just looking at the y-axis and the origin when something asks you if it's even or odd. Since both of these were no, this one is not even, it's not odd, so we would say that it was neither. So that would answer the question for this particular problem.